Hello, Year 7, and welcome to today's lesson. We're going to start with true-false questions. The first question, liquids can be compressed. Is this true or false? Number 2, solids have a high density as the particles are packed very closely together. True or false? 3, gases have no fixed shape. True or false? 4. Diffusion happens in solids because the particles are able to move in all directions. True or false? And lastly, number 5, diffusion happens in liquids because the particles are able to change places. Is this true or false? Pause the video now and write down your answers. Okay, these are the answers. For the first one, it is false. The second one is true. The third one is true. The fourth one is false, and the fifth one is true. Give yourself a mark out of 5, and well done if you got them all right. Today's title is called Gas Pressure. Make sure you write down the title in your book. The learning outcomes are, I can use the particle model to explain gas pressure. I can describe the factors that affect gas pressure. The keywords today are pressure, collide, temperature, and particle. Did you know if you took a bag of crisps on a plane, after takeoff the bag would have expanded? Why do you think that might be? Right now where you are, there are gas particles moving and colliding. They are always moving. The gas particles are always moving. When they hit you, they cause a force. This causes a pressure on you. What is gas pressure caused by? Have a little think. When particles are hitting against a container or against a surface, they put force on that surface. And this is known as gas pressure. We feel gas pressure all the time, except that we're not really aware of it. When the wind blows on you, that is the pressure of the air particles on you. This pressure is the same for everyone, and it is the same on every part of your body. The air pressure is affected by two things. What do you think those two things are? What can affect gas pressure? The first one is quantity or amount, and the second one is temperature. So when we're talking about quantity, we're talking about the number of particles present. And when we're talking about temperature, if the temperature increases, it will affect the pressure of the gas, and if it decreases, the pressure of the gas will also be affected. If you see the picture at the bottom where somebody's balloon has popped, maybe that's happened to you before, where you've blown up a balloon and you've put it on the windowsill on a hot sunny day, and suddenly it has burst open. The higher you go up a mountain, the less pressure there is. Why? If you look at the picture, up a mountain, you've got fewer gas molecules or air particles. There are less air particles the higher you go, less force is exerted on you. Therefore, there is less pressure. So that means that the air particles are putting less force on you. A balloon with high pressure has lots of particles inside that are colliding with the walls of the balloon to keep it inflated. And one with low pressure has less particles colliding with the walls of the container, which means it is going to be less inflated compared to the one with high pressure. So what are particles doing again? Let's see if you remember. They are moving and colliding, which exerts force on us. That means it is putting pressure on us. Can you tell me the pressure difference if I showed you this picture? So look at the picture of the mountain. Is there a pressure difference, or what is the pressure difference? Sorry. What is the pressure difference at the top and at the bottom? If you said at the top of the mountain the pressure is lower, you are correct. And at the bottom, if you said higher pressure, well done to you. This is because there are less particles higher up the mountain, as we saw in a previous slide. Particles move faster as the temperature is increased. This means more pressure. If you remember last week when we looked at the particle model, we said that when particles are moving really fast, there's a special scientific terminology or scientific word that we use. When molecules or particles are moving really fast, we say that they have kinetic energy. And the kinetic energy increases when the temperature increases. So this allows the particles to move faster and therefore increase the pressure in a container. However, if it is cold, the particles will slow down, which will produce less pressure. Why is this? It's the opposite of what we just said. It means they've got less kinetic energy and therefore they don't move as much, which means they are slowing down and they are not colliding with the walls of the container. This means that there is less pressure on inside the container. We saw this question at the start of the lesson. Did you know if you took a bag of crisps on a plane, after takeoff the bag would have expanded? The reason is, as you take off, you are going into less pressure atmosphere. Less pressure on the outside of the bag means there is more pressure on the inside compared to the outside. Therefore, the bag will expand. I would like you to pause the video now and complete the task on your screen. The keywords to help you fill in the gaps are shown at the top of the screen. The keywords are higher, pressure, fast, more, number, particles, less. The first one, gases are made of something that moves something. Now, when I say something, you need to choose from the keywords which will be the right ones to go in those gaps. Number two, the something of the particles hitting the sides of the container causes the something. Number three, something particles means more pressure. Number four, faster moving particles means something pressure. And number five, water liquid exerts something pressure than water vapor. Pause the video to fill in the gaps. Let's look at the answers. Gases are made of particles that move fast. The number of particles hitting the sides of the container causes the pressure. More particles mean more pressure. Faster moving particles means higher pressure. Water liquid exerts less pressure than water vapor. So, so far, let's look at our learning outcomes. I can use the particle model to explain gas pressure. I can describe the factors that affect gas pressure. You should be able to do this now. Why does a can do this? There is more pressure inside the can than outside the can, so the gas moves quickly, which causes it to spray. And if you notice, if you leave a can of Coke or a bottle of fizzy drink out and you take the lid off, after a while, it's no more fizzy. And that is because when they're making these drinks, they put the carbon dioxide, which causes the fizz, they put it inside the drink under pressure. So when you open the top of the bottle or you pull the ring so that because you want to drink your drink, you are allowing the gas particles of carbon dioxide to escape. Now, on the next thing we're going to do is you're going to watch a series of experiments on the next section. Hi, Year 7. What is gas pressure? This is the force exerted by gas particles. It is caused when the gas particles hit the walls of a container. The more often they hit the walls and the faster they are moving, the higher the pressure. I'm going to demonstrate 3 experiments to show gas pressure. First experiment is a reaction between hydrochloric acid, which I've poured in a measuring cylinder, and I'm putting it into a conical flask, and calcium carbonate, which is like chalk. So I'm just going to put a spatula full into there and try and capture the gas that is in there. As you can see, it is being inflated. Why is the balloon getting bigger? That is because the carbon dioxide being released from the experiment is hitting the walls of the container, and therefore it is inflating the balloon. We'll come back and have a look later to see how much the balloon has inflated. The next experiment is called the collapsing can experiment. Now, some of you might have seen this demonstrated before. What you do is you put a small volume of water in an empty can, and then you heat it up until it boils, until you can see the steam. I don't know whether you can see the steam coming out of the can. What do you think happens as it is heated up? Think back to the particle model. You can pause the video now just to have a go. Okay, the gas particles have a lot of kinetic energy, and they are moving very fast. They are colliding with the walls of the container. What do you think will happen if I put this can into an ice, a bowl of containing ice and water? Let's see. Okay, so I'm using tongues in order not to burn myself. Whoa, did you hear that, guys? And did you see how the can collapsed? What do you think happened here? So we've gone from a round can to almost a squashed can. Let's do that experiment one more time. Okay, we're going to use another can to try and demo the same thing. Okay, I must admit I do not drink beer, so this is not my beer can. Maybe Mr. LePage does. Mr. LePage, is it yours?
I do drink beer.
Oh, well, maybe it's Mr. LePage.
Especially Stella, which is good beer.
Okay, I'm going to put it in water again. Whoa, that was even more dramatic. Okay, so what do you think is causing the particles to, the can to collapse? So think about what is happening with the particles. Again, go back to the particle model. The third experiment is one that you can do at home. So what I would suggest is get two balloons of the same size, blow them up to an equal size, roughly an equal size, and then put one in the freezer for maybe about an hour. Now this one hasn't been sitting there long, but what I would like you to do is to compare what the balloons look like side by side. What happened? And can you email your teachers as to what you think happened, both for the collapsing can experiment and for the balloons? So I don't want to put the balloons side by side for long because I want you guys to actually do the experiment. So two things you need to do. The collapsing can experiment, why did it collapse, as the cans that we can see? And the second one, what is the difference between the two balloons, one in the freezer and one at normal temperature? Can you send your answers in? Thank you. I would like you to pause the video now and complete the task on your screen. Right, I hope you did that. You saw the demonstration of a balloon being inflated and also a balloon being put in the freezer, as well as having one at room temperature. Let's look at the answers for these questions, sorry. The first one, what are the particles inside the balloon doing? What are the particles doing inside the balloon? Circle two answers. You should have chosen moving and colliding. Number two, draw the particles onto the picture of the balloon. Show the particles like this. So if you look at the top of your screen, you can see what they look like. The little arrows are showing the direction in which the particles are moving, and they are moving in all directions. Number three, why is the balloon inflated and staying that way? The particles are colliding with the walls of the balloon. This produces pressure and this keeps the balloon inflated. Number four, what has the cold temperature of the fridge done to the particles? How are they behaving? It has slowed them down. The particles have been slowed down. Why has this caused the balloon to deflate? Tick the correct answer. So is it the slower moving particles produce less pressure on the walls of the balloon so it shrinks? Or the walls of the balloon are cold so the balloon deflates? Or the air inside the balloon escapes when it is cold so the pressure of the balloon changes? Or the freezer has less oxygen than normal air, so the balloon shrinks? If you chose the first one, you are correct. Looking at the two diagrams on your screen, which can has more pressure? Think back to the demo that you saw as part of this video. Is the can on the left, does that have more pressure than the one on the right? Or does the can on the right have more pressure than the one on the left? If you said the can on the left has more pressure, you'll be correct. This is because the particles inside the can are at a higher temperature. This means the particles have more kinetic energy, they are moving really fast, and that means that they are colliding against the walls of the container. They're constantly hitting the walls of the can, and therefore the pressure inside the can is higher than the one on the right. Before the experiment, there was an equal pressure between the can and the outside. So the pressure on the outside and on the inside was exactly the same. As the can is heated, the gas is expelled. That means it is forcefully removed from the can. And then the water turns into steam, which increases the pressure inside the can. When the can is put into cold water, the water vapor quickly condenses back to liquid water, which quickly reduces the pressure compared to the outside. The pressure of the outside overwhelms the pressure on the inside of the can, so it crushes. So that means that the pressure on the outside is more than the pressure on the inside, because we have reduced the temperature of the can very quickly. Pause the video now and do this task. Use the words above each picture to explain that part of the experiment. So you're using keywords for the first diagram, keywords such as pressure, outside, inside, equal, and can. For the second diagram, the keywords you'll be using: heating, increase / decrease, pressure, walls of the can. And for the third diagram, the keywords you need to be using are cold water, water vapor, condense, decrease, pressure, walls of the can, surroundings, and implosion. Okay, let's see how you did. If you've not done it yet, please make sure you pause the video and have a go. So the kind of thing that you should have written would be, for the first diagram, the pressure outside and inside the can are equal. For the second diagram, heating increases the pressure on the walls of the can. For the third one, when the can is placed in cold water, the water vapor condenses. This decreases the pressure on the walls of the can. The surrounding pressure is higher, which causes an implosion of the walls of the can. Implosion means it has caused it to collapse on the inside. Let's look at the learning outcomes one more time. So by now, you should be able to use the particle model to explain gas pressure. And you should be able to describe the factors that affect gas pressure. Let's look at a summary of what you have learned today. All particles around us are colliding with us, which causes pressure on our bodies. The reason we don't really feel it is because the pressure inside our bodies is equal to the pressure on the outside. The times that you do feel a little bit of pressure on the outside is when it's really windy and the air particles from the wind are pushing against you. Pressure depends on two factors: the temperature and the quantity or the number of particles. And lastly, a can collapses when the pressure outside is greater than the pressure on the walls of the can inside. This pressure difference occurs when water is heated inside the can and then it is quickly cooled. I hope you enjoyed today's lesson, and I hope you understood what we have done. If not, I would suggest watch the video again and go over the areas that you are not sure of. Bye.